We are back on our discussion, this time about nuclear chemistry. In this topic, we'll discuss balancing nuclear reaction. In our previous discussion, we compared chemical reaction with nuclear reaction. The comparison, we discussed that a chemical reaction occur when bonds are broken, whereas nuclear reaction occur when nuclei emits particle or rays. Likewise, in a chemical reaction, atoms remain unchanged although they may be rearranged. In the case of nuclear reaction, atoms are converted into atoms of another elements. Therefore, balancing nuclear reaction is totally different like what you have done in your general chemistry when balancing chemical reaction. In a chemical reaction, you observe the law of conservation of mass by balancing the number of atoms of each element in the reactant must be equal to the atoms of the element present in the product. In balancing nuclear reaction, the nuclear reaction is balanced when the total number of protons plus the number of neutrons in the product and in the reactants are the same, and this is the conservation of the mass number. The total number of the nuclear charges in the product and in the reactant are also the same, and this is observing the conservation of atomic number. This can be done by considering the following elemental particles as either reactant or product. These elemental particles are proton, symbol P, or the symbol for hydrogen, with an atomic number of 1 and a mass of 1. And the mass is approximately 1 atomic mass unit and a charge of positive 1. Whereas neutron with a charge of 0 and a mass of 1. An electron or beta particle with a charge of negative 1 and a mass of 0. Or a positron, which is symbolized as positive electron or a positive beta with a mass of 0 and a charge of positive 1. Or an alpha particle, which can be represented by an helium atom with a charge of positive 2 and a mass of 4. Or the alpha symbol with a charge of positive 2 and a mass of atomic mass unit. Or a gamma, which has a charge of 0 and a mass of 0. Okay, let us apply this technique of balancing nuclear reaction. A nuclear reaction is balanced when the total number of proton plus the neutron in the product and the reactant are the same. That is a way of conserving the mass number. Or the conservation of atomic number is applied when the total number of nuclear charge in the product and in the reactant are the same. Let us have some example to illustrate the technique in balancing nuclear reaction. Okay, to illustrate the technique in balancing nuclear reaction, we are asked to balance the following nuclear reaction. For the first number, we are given here polonium-212 with the atomic number of 84. This is your reactant, and your product is lead-208 plus a blank. So, we have here the atomic number, which is denoted by the charge, which is the number of proton, must be equal. The reactant and the product must be equal. So we have here 84, we have 82, so we must have 2 here, and 212 minus 208, that would give you 4. So we have a particle with a mass of 4 and a charge of 2, that is your helium. Okay, or an alpha particle with an atomic number of 2 and a mass of 4, or a charge of positive 2 and a mass of 4. Okay, so that's how you balance a nuclear reaction. The mass number of the reactant and the total mass number in the product must be equal. Likewise, for the atomic number, which is the charge, referring to the charge, the number of proton in the nucleus. Okay, we have 84 in the reactant, we have 82 plus 2, that gives you 84. Okay, we have balanced reaction. Okay, next we have here cesium 55, and we have barium here 56, and the mass number is 137. So 137, so it has a mass of 0. The particle here must have a mass of 0. And you have 55, 56, so this must be equal to that. We have deduct 1. 56 minus 1 is